The Fermi Paradox is named after physicist Enrico Fermi and refers to the apparent contradiction between the high probability of extraterrestrial civilization existing in our galaxy and the lack of evidence or contact with such civilizations. The paradox is often summarized by the question, "Where is everybody?" The paradox emerged during a conversation in the summer of 1950 when Enrico Fermi, along with other scientists, were discussing the possibility of intelligent extraterrestrial life. Fermi made a simple observation. If there are many technologically advanced civilizations in our galaxy, some of them should have colonized the entire galaxy by now, or at least we should have received some form of their signals or probes. However, no convincing evidence of extraterrestrial civilization has been found. What is drag equation? The drag equation is a formula devised by astrophysicist Frank Drake in 1961 as a way to estimate the number of technologically advanced civilizations that could potentially exist in our galaxy. The equation is where n is the number of civilizations in our galaxy with which we could communicate. R is the average rate of star formation per year in our galaxy. Fp is the fraction of those stars that have planets. Na is the average number of planets that would potentially support life per star with planets. Fl is the fraction of those planets that actually develop life. Fi is the fraction of planets with life that develop intelligent life. Fc is the fraction of civilizations that develop technology capable of communication. And L is the length of time such civilization relays detectable signals into space. The Fermi paradox is related to the Drake equation in that it highlights the disparity between the high probabilities of extraterrestrial civilization predicted by the equation and the lack of evidence or contact with them. Despite the vast number of potential civilizations estimated by the Drake equation, we have yet to observe any direct proof of their existence. Due to the large number of stars in the present day, Milky Way considering the known rate of star formation can be misleading, given that there are about 200 to 400 billion stars. The rate of star formation today is very different from what it used to be. Instead, take 300 billion as a starting point and find out how many stars there are in the galaxy today. To do this, start at one end of the equation and continue adding while working backwards. Now, let's look at the fractional part of this sum. Like the stars, the assumption that red stars are unsuitable for the existence of habitable planets is perhaps a conservative assumption. Today, we have a pretty good understanding of it, thanks to the space observations such as NASA's Kepler's program. There are about 18 sun-like stars, which is equivalent to her 54 billion stars. The proportions included in the habitable zone is thought to be about 1 to 2 in the solar system. Going from 1 to 5 leaves 81 billion planets in the Milky Way's habitable zone. The next step is to estimate the number of planets suitable for life, and this is where the complex work really begins. Life as we know needs a terrestrial planet that's the right size with a giant planet like Jupiter protecting it from asteroid impacts, a natural satellite like the Moon to help stabilize its orbit, a magnetic field, and tectonic plates for volcanism, and an atmosphere that has the right chemistry. And just because there are some conditions on Earth-like planets doesn't mean it's habitable. Let's say there are only 20, we are left with 16 billion planets that can actually support life. Let's assume a 50 chances that life will arise as long as the conditions are right. This brings us down to 8 billion life-hosting planets. The next parameter is about intelligent life. It's possible that complex life is common while intelligence and consequently civilizations are not. Since we don't know the frequency of complex life, then the prospect for intelligent life are uncertain. Is it even necessary from an evolutionary point of view? It took 500 million years on Earth just to create civilizations, and along the way there have been several mass extinctions that have impacted evolution. This parameter is basically impossible to say anything about, but taking an average from multiple scientists, we will end up with a 20 chances of success down to 1.6 billion civilizations. In total, how many of these civilizations will develop a technology that potentially can release detectable signals of their existence into space? It's possible that advanced civilization exists, but we are simply not technologically equipped to detect these signals or communications. The vast distances and timescales involved in interstellar travel and communication could make it extremely difficult for us to make contact. Let's assume 50 and 800 million high technological civilizations may choose not to reveal themselves for many reasons. If civilization is broadcasting, it will not coexist in time with a sun-like star that has an average lifespan of 10 billion years. The first and last billion of years of life on Earth are not particularly suitable for life to exist on Earth-like planet. So there is very simple explanation for why the Fermi Paradox exists. Life forms have not discovered us yet. Over the years, scientists have been able to come up with some solutions to this paradox. One solution is that we are living in a simulated universe, where our reality is computer-generated simulation. This theory suggests that the absence of extraterrestrial civilization could be a result of the simulation's design or limitation. Rare Earth hypothesis. This suggests that the development of complex life, let alone intelligent life, may be a highly improbable event. It posits that the conditions required for life as we know it are so unique that they rarely occur, explaining the absence of contact. Great filter. This hypothesis proposes that there might be a significant barrier or hurdle that prevents civilizations from advancing beyond a certain point. It could be related to the challenges of developing technology, ecological collapse, or self-destruction, which would explain the absence of advanced civilizations. Technological transcendence. It is possible that highly advanced civilizations reach a stage where they move beyond physical forms or dimensions that we can comprehend. They might have transitioned into advanced virtual realities or exist in ways that are currently beyond our understanding. It's important to note that the solutions proposed for the Fermi Paradox are speculative and lack conclusive evidence. The paradox continues to inspire debate among scientists, and the search for extraterrestrial intelligence continues in hopes of eventually resolving this intriguing question.